Okay, number 9 and 10, we have two sets of resistors, a 3.5 ohm resistor, a 7.8 ohm resistor, and an 11 ohm resistor. They're connected to a 24 volt battery, but in number 9 they're connected in series, okay? So I'm just going to sketch it out. Here I have my 24 volt battery, and then here I have three resistors in series, okay? And in this case it's given as 3.5 ohms, 7.8 ohms, and 11.1 ohms, okay? First question is find the equivalent resistance of the circuit. Okay, we're going to find what's called R equivalent or R total. Well, in a series circuit it's pretty easy. The equation you use to find the total resistance is just R1 plus R2 plus R3, etc. In other words, in series the resistance simply adds up. Okay, so all I do is I add up 3.5 plus 7.8 plus 11.1. I'll get my total resistance of 22.4 ohms, okay? So in this case, R1 plus R2 plus R3 is just the sum of all three. And what do we get again? We got, what, 22.4 ohms, okay? So that's my first part of the question, 22.4 ohms. Then I want to find the current in the circuit. I is for current in amps. V was 24 volts for voltage. Okay, so now we can use our Ohm's law triangle. If you remember, the Ohm's law triangle is pretty easy. If you draw a triangle, we have V, I, and R. If I want to get I is just V over R. So in this case, I put in for voltage 24. For resistance, it's 22.4. Okay? So if I take out my calculator, I just do 24 over 22.4. I'll get my final current of 1.07 amps, something like that. Okay? So this one's pretty straightforward in terms of using Ohm's law, and in series you just add up the resistance, okay, for number 9. Now we're going to go ahead and do number 10, which is the same idea, but in this case we arrange the resistors in parallel. Okay? So what's different here? Here we have our battery, but now the resistors split. And in parallel it's a little bit trickier because the resistance doesn't add up. In fact, the resistance goes down, okay? In parallel, the trick is to find the total resistance. You have to use the equation in parallel. It's 1 over R1 plus 1 over R2 plus 1 over R3 is equal to 1 over R total. But what I like to do is raise this whole thing to the negative first power. It's the same thing, it's just you flip all the numbers. So in other words, if we go ahead and plug and chug for step 4, it's going to be our total is equal to 1 over 3.5 plus 1 over 7.1 plus 1 over 11.4, and then you have to raise the whole thing to the negative first power. It's 1 over that. In other words, in parallel the resistance goes down because it's like you have a 3-lane highway instead of like 1 lane of traffic, okay? So again, watch out for order of operations. To find the equivalent resistance in parallel, this will be 1 over 3.5 plus 1 over 7.1 plus 1 over 11.4. Let me make sure I type that in right. 3.5, 7.1, 11.4, there we go. And then the whole thing has to be raised to the negative first power to flip it, okay? So the equivalent resistance is only 1.94 ohms. So it drops down to almost 2 ohms because we put them in parallel. It's like a 3-lane highway. And then we can find the current I. It's just equal to V over R. V is 24 volts. Resistance is 1.94 ohms. So if I do 24 over 1.94, I'll get my final current of like 12.3 amps. A lot more current this time, okay? Because we're hooking them up in parallel. 12.37 is what we'll round it off to. Okay, so in summary, 9 and 10 are the same problem. It's just one is in series, one is in parallel. In series, the resistance adds up. In parallel, the resistance goes down because you split the current into 3 branches. And there you have it, 9 and 10.